Let's continue our discussion on modern physics. This is Photoelectric Effect, lecture number 2. Who is this talking? समझ नहीं आता क्या कि लेक्चर स्टार्ट हो गया, चुप रहना चाहिए एकदम. Yes, so last time I think we left off on this Einstein's theory of photoelectric effect, and then we were building the idea that we actually tried to not go by this idea but rather with wave theory, and we found that we are not getting the correct results at all. And then we said there was a person who did something else. He was working on a different problem, a black body problem, and that was Max Planck, and he said ki it's much better if in this instances you should assume that the light is made up of packets of energy, and those packets of energy were called to be quanta. Einstein went a little further, and then he said ki rather than calling them just packets of energy, let me call them the particles of light. The particles of light, and he called them to be photons. So let me write it. He said that the particles, or rather the packets of energy, can be assumed to be particles of light. He called them photons, called photons. What is the energy of each photon? That's h nu, where nu is the frequency of the source. Yes? And now let's come back to our experiment, and with this understanding let's try to check whether we will get the correct result or not. Okay? So what was the photoelectric experiment? You have this metallic sheet. Yes? Let's say there is a source, and from this source what happens is a photon comes. A photon comes, hits this thing, and then the electron comes out. When will the electron will come out, by the way? If you remember, I introduced this something called as phi last time. What was phi defined to be? See, each nucleus is holding or binding the electrons, each electron, right? They are holding each electron, and how much energy should you give so that the electron comes out? That is that phi. If you remember, even in hydrogen atom, this is my electron. Let's say the electron is in ground state. What is the electron, the energy with which it is binded? The energy with which it is binded to the nucleus? Minus 13.6 electron volt. If you give plus 13.6 electron volt energy to this, the electron will escape. It will escape the nucleus influence. So there is some energy with which the electron is binded to the nucleus, right? Yes or no? And thus it's not only special for hydrogen, you can even extend it to any atom that you have with some Z charge Ze in the nucleus and the electron of the outermost orbit. So how much amount of energy do you need to provide, the positive energy, so that the electron comes out of the influence of the nucleus? That's called the phi. That is the phi. That is the minimum energy that you will provide so that it will come out of this thing. So let me define the phi. Minimum amount of energy if provided to the electron will escape the influence, the binding of nucleus. Yes, And now you tell me the photon that is carrying some energy, what is its job? It's going to give this amount, whatever amount of energy it carries, to the electron so that the electron may escape. Huh? When will it escape? When the energy carried by the photon is at least equal to phi or it is a little greater than phi. Only then the electron will escape. So what should be the condition on photoelectric effect? The condition of photo of PE effect should be what? It should be that your EP should at least be greater than or equal to this phi. Yes or no? If it is less than phi, what will happen then? The photoelectric effect will not occur. Why? Because the electron will not be able to escape. Are you understanding? Yes or no? So your EP, if it is less than phi, no photoelectric effect. But if it is greater than this, then there is photoelectric effect. Are you understanding this? Yes? These are conditions on energies. But what is the energy carried by this photon? What is the energy carried by this photon? H nu. So this H nu, there's a condition on frequency as well then. Should be greater than equal to this, and nu should be greater than equal to phi by h. Yes or no? It should be greater than this value. Acha, when will this become equality? That is the minimum possible frequency, na? That borderline frequency. If you go above this borderline frequency, the photoelectric effect will surely occur. If you go below this, it will never occur. So there is a borderline frequency nu which is equal to phi by h. Yes or no? And I am going to call this nu a special name. Let me write it to be nu th. And do you know the name of this? That's called the threshold. The threshold. The threshold value, it's also written as nu naught in some books. Yes? So this is the threshold frequency. Do you understand? Then this phi, whatever you have this phi can even be written like this. H nu naught. And this phi is also given a special name. It's called to be the work function. It's called the work function. Do you understand? Let me ask you this. If I have two materials, will the phi depend on the material or will it not? Two different materials. Phi is what? Phi is what? Phi is the amount of energy that you provide so that the electron escapes. Yes? And the electron, how much energy do you have to provide? That depends on how tightly the nucleus is holding the electron. Yes or no? How tightly? So that depends on the nuclear charge, na? If you remember, if I let's take the simple example of nickel and cobalt. What is the atomic number of nickel? 28. What about cobalt? I don't remember either, so whatever is. Let me say, one of them is 27, one of them is 28 maybe. Whatever. So that means what? How many protons? 27 protons, 28 protons. If I take 2 electrons in the outermost orbit, which of them will hold the electrons much more strongly? 28 wala. So it is going to hold the electron much more strongly. That means you have to provide more energy so that it escapes. So the amount of energy that you have to give, that is the phi, depends on the material, na? Depends on the material chosen. Does it depend on anything else? No. So your phi is dependent on this, depends on material chosen, on material of sheet. Are you understanding whatever I am saying? These are the things that we have. And now let me say this is the equation that I have, that's all good, but let's say the minimum energy that you needed for the photoelectric effect to occur was 20 joules, let's say, and the amount of energy carried by the photon is 100 joules. Then where will the rest of the energy will go? So 20 joules will be used to escape the electron. Where will the 80 joules of energy go? That will be used in the motion of the electron. And the energy associated with the motion of electron is kinetic energy. It helps in the movement. So if I say by conservation of energy, what is that h nu used in? It's used in two parts. One part to free the electron and one part for the motion of the electron. Let me write it Ke. Then by conservation, what can I write? I can write that h nu should be equal to phi plus Ke. And Ke of what? Of electron. So I should write it like this, Kee, to signify it is electron. And what is the formula of kinetic energy? Half mv square. I can write this phi to be h nu naught plus half, and let me write mev square. That is the mass of electron. So what will the equation become then? Half mev square is equal to h nu minus nu naught, and this is the equation of photoelectric effect. Please wait. Please understand, whatever I have been writing, all these equations and all these arguments, these are just theory. You have no idea whether this will work or not. Einstein has been trying to build up this theory, all these equations with the idea of Planck. He has no idea whether this will work or not. The only way to check whether your theoretical predictions is correct or not is to check it with the experimental results. Yes or no? I need to have some kind of graph or some equation which I can check experimentally, and if that matches, then I will say all of this is correct. Otherwise, it's all speculation. Yes or no? So I will go further. Achha, by the way, you can equally write it in terms of lambda. What will be the equation then be? So this can be equally written as half me v square hc 1 by lambda minus 1 by lambda naught. And now hopefully you get it कि there are two more conditions of photoelectric effect then. What are the other conditions of PE effect? Ki your frequency of the source, remember that nu is the frequency of source, and that nu naught is the threshold frequency. If your nu is greater than threshold, then what will happen? If nu is greater than threshold, then what will happen? Batao, will the photoelectric effect occur or not? It won't occur. If I did not say nu equal to nu naught, I am saying nu greater than nu naught. Will the photoelectric effect occur or not? It will occur. Yes, with some kinetic energy. Even in this case, it will occur with zero kinetic energy. So this is the condition of occurs. What about this? Does not occur. I can equally write some more conditions like this. What about what will be the condition on wavelength then? Achha, what is that lambda naught called, just for what? That's called threshold wavelength. Okay? What should be the condition on wavelength then? Batao, should I write something like this? Let me ask you this. What will occur in this condition? If lambda is greater than lambda naught, will the photoelectric effect occur or not? It will not occur. Yes, because nu and wavelength are of inverse relationship. You take the reciprocal and then you will find does not occur. What about if lambda is less than equal to lambda naught? Occur. Do you understand? all the things that I'm saying? Please write till now and then say. हाँ बोलो.
Photon is projected with some energy which is more than threshold energy. Then will it not release more than one electron?
Meaning?
For example.
No, one photon will only be responsible for ejection of one electron. Only with this.
Why can't it, if we are giving 100 joules, if threshold?
That photon, please, the thing that should come to your mind whenever I talk about photon is not any particle that you have seen already. You should not think of maybe a rock or maybe sand particle or something. Go by the description that Planck gave. What was the description of photon? It's a packet of energy. That's the only thing that you should be concerned with. It contains energy and rest and nothing else. Yes? You are providing energy only to that electron. So when I say that one photon is hitting one electron and a photoelectric effect is occurring, that means only one photon is responsible for one photoelectron. Acha, the electron that comes out is called photoelectron. Okay? So one photon, one photoelectron. One photon will not give two photoelectron. Please remember that. You will not even say two photon gives one photoelectron. This is not true either. Do you understand?
So what will happen to the photon after that photoelectron?
Energy absorbed. What was photon? Energy absorbed, khatam, transformed in some other ways. Yes? That's why I keep on saying don't assume it to be ping pong balls or maybe some sand particles or something. It's not that.
But it has some mass, right?
It doesn't have mass. That's what I said yesterday as well. It doesn't have rest mass. Anyways.
But according to chemistry, proton.
According to? बोला आगे.
Proton has some mass, right?
Proton. I'm talking about photon. Good. So, can I go forward then? It's written. Now I have this well established theory. I have an equation and I want to check whether my theory is correct or not. Yes? But to actually experimentally check these things is a little harder. Chup. To actually experimentally calculate, how will you able to calculate the velocity of the particle which is coming out of this sheet? It's a hard task. One thing that you can check here, the thing that is constant. What is constant in this equation? Tell me. H is a constant. Nu naught is for a material is a constant. Nu naught will not change. What about mass of electron? Constant. That's also a constant. The things that are variable are velocity of the electron and the frequency of the source. You can keep on changing the source. So those are things that you can play around with. So if you really want to check whether my experiment, whether my equation is correct or not, you can do this. Maybe you can change your source frequency and then keep track of the velocity of electrons. But how to keep track of velocity? That's a very hard task. So rather than that, we'll try to make another equation which you can actually experimentally check. Okay? And we are going towards that now. Is it written till here? You tell me that. Okay. अब मैं थोड़ा tangent लूँगा. Since you don't know electrostatics, so I have to introduce some things. So it will take a little bit more time than usual, but ठीक है. ध्यान से सुनना. So ध्यान से सुनो, okay? You remember that if you have a mass here m and a mass here m naught, and the distance between them is r, what was the force? G mm naught by r square. This is the force. But even though you have this, acha, by the way, if I study this force, then I can talk about the whole dynamics of the system. You understand the meaning of dynamics? The whole motion of the system you can study just by looking at this force, just by calculating this force. Yes? But still, if you remember in gravitation, you actually put another quantity after this. Do you remember that? You actually introduce one more quantity after the force. Do you remember? It's called gravitational field. You introduce this quantity and you introduce it in such a way that the field due to the mass m, let me write it, field due to the mass m is defined to be the force of gravitation divided by m naught. ऐसे define करते थे ना? Yes or no? And then if you get it, you get this formula gm by r square. If you can study everything about the motion just by looking at the force, why did I even define this field? What is the use of this quantity?
So it can predict like up to what extent the mass will act.
Up to what extent the mass will act?
The force of mass that will.
Somebody else also gave me this answer. I don't know why you think that. This r, does it have any bound on it? See, the gravitational force due to the black hole which is at the center of the galaxy, that force is still acting on us. Even though the force is very, very small, doesn't mean it does not exist. There is no bound on r. R can take any values from 0 to infinity. Yes, there is no bound on it. So, what's so different? Why did I introduce this idea of field? Anybody answer? Why are we introducing this idea of field? Batao, when you were studying gravitation, didn't this question come into your mind? Because most of the times maybe you don't even calculate this force, rather you calculate fields. Why?
Maybe because the kinetic energy in the electron which we lost after it.
Kuch bhi.
Out of that.
I'm not talking about electrons or anything, I'm talking about two masses, any general masses m and m naught.
They have a certain set of range.
There is no range, that is what I am saying. There is no range on r. R can take any values.
Area under it cannot be neglected.
There is nothing like this. What is the meaning of force? Let me ask you this. Let's go back to the question of force. ये तो मैंने ही बताया था ना तुम लोग को? मैंने Newton's laws पढ़ा है. बताओ. What is force? Give me the simplest possible thing that comes to your mind. A force is a push or pull. A force is a push or pull. You have this m, and then you put this m naught somewhere from infinity and put it here. When you put it here, then what is the push or pull that it experiences? That is given by this formula. Yes or no? The push or pull that the m naught experiences, that is given by that formula. And now tell me, this force, does it have any dependency on m naught? It obviously has a dependency, it comes into its formula. What about this field? It's giving me exact same formula, but there is no mention of m naught. There is no mention of m naught. Then this formula is independent of m naught ka existence. Then what does the field actually tell you? The field tells you, what does the force tells you? If you have a m somewhere, you bring m naught somewhere, what is the force experienced by that m naught due to this m? This is what the formula is telling me. What will this formula tell me? If you put a mass m in the space, at every point, how much influence can it give? Irrespective of m naught. That is this formula. That is what the formula is telling me. It is independent of existence of m naught. As soon as I put a mass m in a space, what is the strength at each point? The strength or the influence that it can give at each point, at each geometrical point. That is what the field is telling me. So in a way, both of them are telling me the influence of m at different points, but this force depends on the existence of m naught and field does not. Do you understand how important it is? Because here you can talk in general and then the equations become much more simpler. You don't have to care about interactions. Do you understand the significance of a field? That's why we deal with fields much more, not forces. Even though field and forces mein tum log ko lagega, what is so different? I am just multiplying with a constant or dividing by a constant. You are not. Here you are talking about interactions. Here you are not. Do you understand the significance of a field? This is the quantity that you introduce in gravitation. What is the next quantity that you introduce? Potential energy. You defined potential energy. What was the potential energy given to be? Gmm naught by R. This is the potential. There's a negative sign or something. I'm not writing that. Then you introduce one more thing. What is that? Huh? You introduce gravitational potential. And what was the potential defined to be? That's U divided by m naught. And this is the potential due to the mass m. And then you see something similar again. You find that this formula has nothing to do with this mass m naught. What was the, let me ask you this now, what is the potential energy what is it talking about? What do you mean by potential energy? No. What do you mean by potential energy? Yes. Yes, exactly. What is potential energy? It's work done. The work done in bringing from the mass from somewhere to somewhere. Do you remember the way in which we used to define potential energy was this? UA minus UB is equal to W of A to B. You remember this definition that I used to write? And then we were not talking about potential energy at a point, but rather change in potential energy. We used to talk about change in potential energy. But how to find potential energy at a point then? How to find it? You define a reference. You remember? You define a reference at point at which you will find the potential to be 0. And most of the time the reference is taken to be infinity. है ना? So if this is 0, then you say UA is equal to W of A to B. And that's basically, what is potential energy basically? Work done. Work done. है ना? What is potential? What is potential? It's also work done in a way, na? You're dividing by a factor, but again it's a work done. So this is the idea that I wanted to share to you, that potential, it does not matter if I talk about gravitational, electric or anything, it's the work done for us. Is it okay with you? अब ये सब तुम लोग पता रहता है, electrostatics पढ़ते, तो I could have written it directly, but let it be. Anyways, now I'm going to write another force and you tell me what should be the formulas. Let me write another force, and let's say I have a force like this.
Sir, what is Vm?
What is? This is the potential due to mass m. Due to mass m. Acha, just for fun, is it being too boring? If it is being too heavy, then tell me, I can skip. Should I? Go with. Follow. Let me ask you this. If you can study everything from force, you are done. But then you say ki for convenience we define electric field. Why are we defining these two quantities? What is the use of these two quantities? You can study everything about the system using these two. Why are you even defining these two? What is the use of that? Chalo, somebody may come up to me and say ki sir, potential energy is maybe important, it's energy. ठीक है, why do we define this then? What is the use of potential? If you remember what was the definition of the U, that was something like this. Something like this, na? This is how you find the potential. To be more precise, let's say A to B, the change in potential, whatever. Then how was the potential? This is potential energy, I keep on mixing. This is potential energy. How will the potential be defined? That will be defined like this. Are you understanding? The potential will be defined like this. You can see actually there is just off by a factor of m naught. You divide the equation, multiply the equation, something happens, and then you can find this equation. Why are we interested in this potential? Because to calculate a vector, you have to know three components. its x component, its y component, its z component, and then you can define the vector. So you have to calculate 3 things and then you can say everything. What about u and v? What kind of things are they? Are they scalars? They are not scalars. Potential energy is not a scalar. Huh? अरे बेटा डॉट प्रोडक्ट है ये, डॉट प्रोडक्ट. It's a scalar, na? And now you understand, even from this equation you can say that the Ex can be written as del V by del X. Do you know this? So actually if you know V, you can create your Ex, Ey, Ez very simply. You don't have to calculate 3 quantities separately. If you know V, you can find those quantities directly. Are you understanding? So it's for our simplicity again. Instead of writing a vector function, I am trying to find a scalar function and it becomes much more simpler. That's why we care about potentials. That's why it's much more easy to talk about potentials. Are you understanding? Instead of finding 3 components, I am finding only one thing, scalar function. Is it okay? If it is too heavy, you can leave it. Yes. It's okay with everyone? Bolo. You have something to ask? This Ex can be found like this. Ey can be found like minus del V by del Y. Ez can be found like minus del V by del Z. If you know V, you can find everything. So if I know V, I need to find only one thing, V. And then you can find everything. If you don't know V, then you find that separately, the vector. And that is much more difficult. Do you understand? So now, ये तो बस ऐसे टाइम पास में बता दिया. होपफुली तुम लोग 2-3 दिन में भूल भी जाओगे, है कि नहीं? But anyways, it's very interesting the things. Why are we introducing those things? Let me write a force and then you tell me what are the other things. I have this kind of force, and now can you tell me the field due to Q? Just by similarity. The field will be kq by r square. What will be the potential energy? That will be kq naught by r. Yes. What will be the potential due to Q? Please see the similarity. So I have not derived those equations. I'm not going to justify why it is following that, but you see ki maybe it should. Is it okay? You will find those equations much more better in electrostatics. Okay? You will derive them. Anyways, so the only thing that you should care about out of all of this is this. ये मुझे देना था इसलिए मुझे पूरा बताना पड़ा. ठीक है? Good. Now let's come back to what we were trying to do. We were trying to find an experimental setup, or rather an equation which you can use in experiments. And then we said tracking of electron is very hard. So rather than that, I want a quantity which I can actually track. So let's see this. Everyone has written till here? ठीक है, मैं आगे बढ़ता हूँ, तुम लोग बाद में लिख लेना. Let's say, अच्छा, what was my setup like? I have this sheet, I have this vacuum chamber, yes, I have this battery, I have this ammeter, and now it is connected like this, and there's a source. Galvanometer used to detect very small current. It's just in general ammeter. ठीक है? You can even put galvanometer if you want. Okay. Anyways, the thing comes, electron comes out. अच्छा, do you know this convention कि the motion of electron and the motion of electric current are opposite? So if electron is going from, चलो मैं ऐसा दिखा देता हूँ ये बैटरी का. If electron is going like this, then what should be the direction of current? उल्टा. तो ऐसा है ना direction of current? ठीक है. And let's say the potential, so ये बैटरी ना what will it do? It will provide potential. ये बड़ी डंडी का मतलब है पॉजिटिव, जो छोटी डंडी इज नेगेटिव. डंडी तुम लोग को नहीं समझेगा ना. बिगर टर्मिनल इज पॉजिटिव, स्मॉलर टर्मिनल इज नेगेटिव. ठीक है. एनीवेज दिस विल प्रोवाइड अ पोटेंशियल. अब मुझे बताओ पोटेंशियल का मतलब क्या होता था. आई डिड ऑल ऑफ दिस डिस्कशन, नाउ यू टेल मी व्हाट डू यू मीन बाय पोटेंशियल. बेसिक मीनिंग. What was potential energy meaning? Work done. What is potential then? Again work done. So what is, on what is this potential doing work? On the charge. On the charge it helps it to move. It helps it to move. It is doing some work so that there is a motion of electron, so that there is a current. That's why we say you use a bigger battery, the current will be more, because the work done is more. Are you understanding? Good. So what is the job of electron, job of battery? Helps in pushing the charge. It can even help in resisting the charge, na? Because let's say if I have this kind of terminal, then my electron is being pushed in this direction, right? Please understand, ये negative of battery है तो ये क्या होएगा, ये कैथोड एनोड क्या बोलते हो तुम लोग, कुछ तो बोलते हो. ये negative of sheet हो जाएगा ना. ये positive of sheet है तो electron gets attracted towards that. What if I change the battery का thing? What if I do this? Then what will happen? What will happen now? The battery is doing work, but is it helping the electron or is it resisting the electron? It is resisting the electron. Why? Because the electron was moving like this, but now it is pushing like this. Yes or no? So now let me tell you this. If let's say something is moving with some energy in this direction, I give energy in the opposite direction, just equal to that. Will it stop? It should stop, na? You are moving with some energy, I give you energy in the opposite direction. Will you stop? You will stop. What is the energy provided by this battery? What is the energy? So if you remember, what was the definition of V? U by Q, na? Acha, Q was that charge on which the work was done. What is the charge on which the work is done here? Electron. Electron, so it should be E. So what is the U? Let me write the V like this. That's potential. This is the amount of, acha, the charge of electron is minus E, na? So let me write it like this, minus E, and this is the potential energy provided by the battery in the opposite direction. The charge was moving. What we will do na, we will do in this experiment ki battery ka jo potential hai na, we will keep on increasing. The more you keep on increasing, the more it will do work to resist, and eventually the electron will stop moving. Yes or no? It will stop moving. So what will be its final kinetic energy? 0. So if I apply work energy theorem, batao, by work energy theorem, what will you write? That this potential energy, this minus EV, should be equal to the change in kinetic energy. But what is Kf? That's 0. What about Ki? Initially the electron was moving, na? So it was moving with some velocity, half mE square. So I think this negative sign and this negative sign cancels, and then at some point you will find that this thing will become EV is equal to half mE square. And this V, I am going to give it a special name. Let me write it Vs. And what is that Vs? That's the stopping potential. The potential you provide so that the electron stops. Are you understanding what I am saying? What was the setup? We tried to stop the electron. We were providing energy in the opposite direction. That's why I flipped my terminals. I flip my terminals, I am providing opposite direction, and this is what we have. And now do you see that now I don't need to track the electron ka velocity. I just need to track this. Yes, which I can change. Yes or no? The battery is in my hand. I can change the potential of the battery. So what will the new equation become of the photoelectric effect? Batao. What will the new equation become? EVS should be equal to H nu minus nu naught, and Vs will be equal to H by E nu minus H nu naught by E. And now you look at this equation and tell me what are things which are constant and what are things which you have in your hand. H and E are constant. What about that nu naught? That's also a constant. What about this frequency of light? That's in our hand, na? That is the source that is in our hand, that is we can change. What about this Vs? That's also in our hand, that's a battery that we are attaching. So now you see that we have an equation that you can experimentally use. Yes or no? Can you, so usually what we do is we make out a graph due to theory and then we compare it with the graph of the experiment. What will be the graph that will be here? Can somebody tell me that? It will become like a straight line with what? What is the slope? So if I plot this Vs, acha, I forgot to say it, but this is called the stopping potential. Stopping potential. What about this nu? That's the frequency of light. And what should the graph be like? See, it looks to me like plus C. What is M? That's the slope of the graph. And what about the y-intercept? Minus H nu naught by E. And now do you understand that's a negative intercept. So where will it cut the y-axis? नीचे. तो फिर ये ग्राफ ऐसा बनेगा. This is what we expect. Now we have a result that you can actually experimentally check whether this is the result that you get. Do you understand? Yes? And अच्छा, ये y-intercept calculate करके what can you find by the way? This h nu naught is again phi, na? So what can you calculate? You can calculate the work function of the material if you know the y-intercept from the experiments. So this is minus phi by E. What can you calculate by calculating the slope of this graph? Let's say you know E. Then what can you calculate? You can actually calculate the Planck's constant and verify whether the Planck's constant is 6.63 into 10 power minus 34. So this is one of the ways in which we determine the Planck's constant experimentally. But I am getting ahead of myself. This is the theoretical prediction. Everything that we have talked about till now is all theoretical, is our imagination. We don't know whether it is correct or not. How will you check whether it's correct? You do experiments and then find stopping potential, find this. And people have done that, and what they found was the graph is exactly correct. Exactly correct. Then what does it say? Now we are in a dilemma now. Don't be happy that we got a positive result. If this is a positive result, then that means the wave theory is not so good. It's not working. And this new idea of photon is one that you should adopt now. And now this is very wrong, or rather this is not working at all. Should we abandon wave theory now? That is the next question that should come. No, you shouldn't. So we will come back to that again. अब लिखो ये पूरा. So let me write it. It works. बोलो. हाँ. I did it a very ill way where people might think मैंने तो ऐसे बैटरी निकाल के की है. No, there are some ways in which you can just by push of a button you can change the terminals.
But still, when the current is reversed, that means the direction of the electrons is also reversed, right?
Not reverse. The electron. What is the potential doing? Pushing. That is the only thing it does. It does work. So it's not like it instantaneously changes the direction. It was moving like this. Now it started pushing in the other side. Maybe it will still give off the current in this direction if the potential is not so good.
But what if the potential potential is more than that velocity of that electron, will it move in the other direction?
Yes, it will start moving in the
kinetic energy final will not be zero, right? It will be something in negative.
but I just want it to be 0 so that I want it to be equal at least. I want it to be equal. Bolo, chao. Did you understand whatever I said? पूरा समझा क्या चल रहा है? कॉपी करो. Bit down. Down का मतलब ये होता है. तो ये थोड़ा अच्छे से लिखना, मैंने बहुत गंदी तरीके से लिख दिया है. I should better my presentation skills. But anyways, टाइम कितना हुआ? 2 बज गए बेटा. हाँ, घर जाने तो जा सकते हो. अरे 2 बजे नहीं, अच्छा 5 बज गए. अब तो जाओगे? अच्छा ठीक है, कोई बात नहीं. We will try to answer that as we go along. For now, the only thing that you can say is we are finding that in some of, is this light चल रहा है कि नहीं चल रहा है? Okay. Sometimes we find that we are finding that the wave nature or the wave description is best to describe it, and one of the times we are finding, actually not once, even in black body we are finding that if you take the photon description, only then you can say anything. Are you understanding? So we'll try to develop our idea as we go along, don't worry. पहले बताओ, छाप लिया क्या? पूरा छाप लिया? जल्दी जल्दी. ना हो जाए. बच्चे को बहुत नींद आ रही है. अब हुए अच्छा, वीरूपाका के साथ ही बैठे हो तुम लोग. कि कभी बीच में ऋतिक नहीं बैठता? हाँ,
पीरियड वाइज चेंज होता है.
अच्छा पीरियड वाइज.
एक पीरियड में
ओके ओके. मेरे पीरियड में सब साथ में बैठते, लेकिन ऐसे है, ये दोनों साथ. बच्चे अच्छे हैं. Can I go on? So we did all of this and we were able to find that we have at least one description through which we can explain the effect. And the description is through photons. But I want to highlight some points now. So is it done? Is it done writing? Let me highlight some important points. तो मैं देख के लिखते हैं, अच्छा रहेगा. Some important points, okay, and some of the points may be repeated, but these are good to remember. Condition of photoelectric effect. When will it occur? When EP is greater than or equal to phi, when nu is greater than or equal to nu naught, when lambda is less than or equal to lambda naught, then PE occurs. Yes or no? What about if EP is less than phi, nu is less than nu naught, or lambda is greater than lambda naught, PE does not occur. Do you get it? How much time do I have? 30 minutes, no? Okay. Is it okay? Let me ask you this. What is the meaning of intensity when I am talking about particles, not waves? On particles, what do you mean by intensity? No. When I am talking about particles. No. Yes, be more specific. What do you mean by intensity when I am talking about particles? Number of particles passing through a given area. That's intensity when I am talking about particles. So, for particles, intensity means number of particles passing through a given area. Yes? And I just told you that one photon will create one photoelectron. Remember that. So now let's say you have a source which has, or rather you have two sources. You have two sources and both of them are following this condition that their frequencies are greater than nu naught. What will you find then? You will find photoelectric effect. Okay? You will find photoelectric effect. But now let's say the sources have different intensities, and let me say that the intensities are given to be I1 and I2, where I1 is less than I2. When I say I1 less than I2, what do you mean by that? What do you mean by that? You mean that the number of photons coming out of the source 1 is less than the number of photons coming out of source 2. Okay? And now tell me, what is current? Electric current. What is the electric current defined to be? That's charge passing through unit time, na? Yes or no? So the more amount of charge that is passing in the same time interval, that will create the more current. More charge meaning more current. So now let's say you have a surface, or you have the same surface again. You have source S1, source S2. This source gives 10 photons. And this source gives 20 photons. And all the photons follow this condition that they will produce photoelectric effect. Which of them will correspond to more current? The second one? Yes or no? So, even though intensity has nothing to do directly with the current, but if you follow this condition, if this condition is satisfied, then after that, if the intensity is more, then the photoelectric current will be more. Do you understand? So intensity does matter. Actually, it does matter only after your frequency is greater than threshold. What if your frequency is less than threshold? Will the intensity has anything to do with current then? The photoelectric effect will not occur. Are you understanding? The effect will not occur altogether. So intensity only matters only after you follow this condition. So if your intensity is more, then your photoelectric current or photocurrent, it's also called photocurrent, the current passing through this due to the the electrons that comes out of the surface, they are called photoelectrons. I forgot to tell you this terminology. You know this? Okay? The electrons coming out of the surface are called photoelectrons, and the current due to these photoelectrons is called photocurrent. Okay? So here I am writing IP1 will be greater than IP2, where what is I1? Intensity of source 1 and I2 is also intensity source 2. Acha, let me be more specific. Let me say ki nu1 and nu2, they are equal and they both are greater than nu naught. You write this condition. Nu1 equal to nu2 and they both are greater than nu naught. Then IP1 will be greater than IP2. Is it okay? So you have two sources which have same frequency, but one of them is a little brighter. Because its intensity is more. So it's a little brighter and that will produce more current. Do you understand? And now let me ask you this. If nu is less than nu naught, does it even matter what is intensity? Then intensity can be anything and still IP will be 0. 0 ampere to be more precise, but 0 whatever. Bolo.
If I1 is less than I2, IP1 should be also less than IP2.
Yes. भाई क्या लिखा मैंने? ठीक है? Are you okay with this? And now if you come back to the statement that I told you yesterday or in the lecture number 1, I told you, remember that I said ki a surface, or no, not the surface, a source with some special features, I wrote quote on quote, some special features will be able to create photoelectric effect. That some special features is talking about frequency. And then I also told you this, if you remember, that sometimes we find that the dim sources are able to create photoelectric effect and bright sources are not able to. And now hopefully you understand, even if your source is very, very dim, if it follows this condition, you will find photoelectric effect. If your source is very, very bright, but it follows this condition, you will not find photoelectric effect. That is not to say that all bright sources will not create photoelectric effect. If your source is bright and it follows this condition, then it will still create photoelectric effect. Yes or no? So everything it has to do with frequency. Frequency. Samjha? Good. This is point number 2. समझा है सब लोग को क्या बोला है मैंने? It's okay with you? Then point number 3. Point number 3 is this. What was my equation by energy conservation? EP is equal to h nu plus phi, है नहीं? Phi plus ke. ऐसे ही लिखा था ना मैंने? And now if you remember this, if you remember, this phi is a constant for a material, na? It's constant for a material. That means if I, let's say, if I carry 100 joules of energy and the needed energy is only 20, then what will happen to the rest of the energy? Gets used in the kinetic energy. Let's say you were carrying 120 joule of energy. You only use 20 joule of energy. Then where will the rest of the energy go? Again, kinetic energy. So whatever is the excess amount of energy that you carry, it always goes to kinetic energy. Yes? So let me write it. Excess. So if EP is greater than phi, implies excess energy always goes to kinetic energy of electron. And now let me ask you this. If your frequency is more than the required thing, then what will happen? Let me take two sources where both of the sources are following this condition, but also nu2 is greater than nu1. Let's say this is given. What can you say about the kinetic energy of the electrons coming out? And let's say I am taking phi1 equal to phi2. I am talking about the same material. What can you say about the velocity of the electron coming out? Which one of them will be greater? Obviously the second one. So V2 should be greater than V1. What about the stopping potential? Can you say anything about stopping potential? Which one? Should be greater than V2, because what was stopping potential? How much amount of work you have to do so that you can stop it. If it is moving very fast, then you have to do more work. Yes or no? So what is, are you understanding this? Is it okay? And now I just want to make two graphs, and after that the theory will be done. Okay? Is it written till here? Acha, this is not the end of points. Remind me, I have to write 2 more points. 3 more points. Remind me. Let me make the graphs. The graph of photo current versus potential due to battery. Okay? And now let's try to guess how the graph will go like. Ki I have this IP which is here, and this is my potential. You remember what was current? Current was amount of charge flown in a given amount of time. Yes? Let's say ki I have a source due to which it has some intensity, due to which some amount of electrons will come out, and the amount of electrons coming out gives the amount of charge coming out. Yes? So, and now what is the job of a battery? What is the job of a battery? Does work. Provides, does work, it pushes the electron. Hai na? How much you can push the electron, there's only a limit to that. Na? It's not like if you have, let's say, if I have the charge to be 2 coulomb, achha, do you know coulomb? Yes. Coulomb pata hai. 4 coulomb, and I am moving it in 1 second, 1 second. Which current will be greater? Obviously this one, because the amount is more. Hai na? Amount is more. If I fix my amount, and let's say I am using my battery, then what will the battery do? The only thing that the battery can do is try to decrease the time taken, na? Because it is pushing it. So you can decrease the time, but you can decrease only to a certain extent. This battery can't be used to infinity so that the electron can be accelerated to infinity. You can't do that. There is only a limit to which you can do, and that means what? What kind of graph look like? There is an increase obviously initially, but afterwards what happens? Becomes a constant. So how should the graph look like? Something like this. And now if I start flipping the battery and increasing the battery potential in the opposite direction, what will happen at some point? It becomes 0. Stops the current, becomes 0. So it should be something like this. Yes or no? Now what is this point of potential called? That's called the stopping potential. What is IP here? What is IP? That's 0 here. Ja. And now let me write it, and then you say. Let me make 2 graphs, and then you tell me what is same and what is different. I have these 2 graphs. Now you tell me what is same in the experiment, what is different in the experiment. So you said ki stopping potential is same. So Vs2 is equal to Vs1. If the stopping potentials are same, then what can you say more? What? What can you say more? What is more? Huh? What other thing is same? The frequencies are same. Yes or no? The frequencies are same. if everything is same, and let's say phi 1 is equal to phi 2, we are using the same material, then why is it different? No, potential you are plotting on the x-axis, you are giving the same potential. What is different in the two sources?
The current.
Why? Why? What is different in the source that makes the current different? The intensity of the source. If you remember, intensity is what? How many photons will hit the surface? If the number of photons hitting the surface is more, it will create more photoelectrons. And that means the charge that is coming out is more and the current will be more. Yes or no? So I am going to write this I1 and I2 and you tell me which is more and which is less. I1 is greater than I2. That means one of the sources is a little brighter. When you have a little brighter source, you will get a graph like this. Are you understanding? Everything else is the same. So source 1 is brighter than source 2. Do you understand? I need to make one more graph. So is it okay with you?
Sir, but the rate at which it increases or decreases the flow, wouldn't it be a constant?
Meaning?
The rate at which it increases or decreases, will it be a constant?
What increases or decreases?
The potential, the battery is trying to, increase the...
The battery is our x-axis, now that's the independent variable.
But what I'm thinking,
What?
should it be a straight line and then a constant?
No. Yes. This is what we find even experimentally. Okay? I mean, I can only tell you characteristics. I can't specifically say why it's like this or that by idea. If you want experimentally, then you will get the correct answer. Okay. Anyways, let me make another graph if this is done. I'm going to make the same x and y axis, but the graph will be a little different. So again, IP versus V, but now I am making the graph like this. I am making the graph like this. And now you tell me what is same, what is different. What is same? Intensities are same, very good. Stopping potential is also same. That's different. So let's say this is Vs2 and this is Vs1. Which of them is greater? Vs1 is greater than Vs2. Hai? At least in mod, since it's negative sign, na? At least in mod it is greater. What about the frequencies? Are they same? They are also not same. So nu2 is greater than nu1. So actually, based on this, you can say the sources are equally bright. Yes, I keep on doing mistakes. So the sources are equally bright, na? Do you understand the graphs? Because the frequencies are different. Okay? Are you understanding everything? The graphs? Let me write 2-3 more points. Let me ask you this. This sheet that I have been talking about, it's not like this sheet has no thickness. Huh? Not that sheet, idiot. The metallic sheet that I have been talking about, it's not like, hey, why are you going? There's only 10 minutes remaining, na? Why can't you wait? Ajeeb bachche. So, the sheet, the metallic sheet that I have been talking about, it's not like it has zero thickness. It has some thickness, that means it has some volume. And now let me ask you this. The photoelectric effect that occurs, does it occur, the electrons that are being ejected out, are this the surface electrons or from the bulk? They are the surface electrons, never from the bulk. So it's a surface phenomena. Okay? One more thing. as soon as the photon hits, will the electron take 1-2 hours or days to come out, or will it instantaneously? It comes out instantaneously. That's one more point. I have to say one more point again. और क्या लिखा था मैंने? हाँ, let me ask you this. This is the most interesting thing. I don't remember if I asked you this question or not initially. Whether photoelectric effect, does it only occur in metals?
Yeah.
He is saying it only occurs in metals. Anybody else with any other opinion?
It can occur in other things if you apply like a lot of.
Correct. That is the correct answer. The only thing that the photoelectric effect depends on is the work function. If you can overcome the work function, then the photoelectric effect will occur. Doesn't matter if you are taking wood or non-metal or a semiconductor. Do you understand? Photoelectric effect will occur if you overcome the phi. So it's not exclusive to metals. Is it okay? So let me write all of that. This is point number 5. So photo. बोलो.
It is applicable for other than metals only theoretically or even practically is possible.
Obviously, practically.
Sir, but won't the material get damaged? Like for example, we take the scenario of wood. If we supply that much intensity of light, won't it?
It's not intensity that you are supplying.
Photons, so that is intensity of light.
It's not intensity, it's frequency. Higher frequency you are applying.
Won't the wood burn or something will happen physically? Like technically,
Let me answer it in some time, okay? I shouldn't answer some things and then it turns out to be wrong and then you say fraud teacher. ऐसा नहीं है. I will answer it later. Photoelectric effect can occur. Okay, with this our theory of photoelectric effect is done, and now we can focus on problems, and probably it will take 1 or 2 lectures, then we will go to X-rays. Okay, so if you want you can try with the question number 1 right away right now, and if you can do it in 4 minutes that's good, otherwise I will start. Please write name at the top of the sheet. बोलो बोलो क्या है बच्चे.
Forget that.
हाँ नेम लिखा है ना
Forget
ऐसे. हाँ बच्चे बोलो.
For the question he asked, I'll tell you an answer. Tell me if it's a valid answer.
ठीक है.
So he said that the wood will get damaged and all.
ठीक है.
Fine, leave the wood. At the end of the day, you want the electron to be separated from the whole thing,
ठीक है.
which is happening even if it does get damaged.
Yes, that could be true, but I don't want to make a general statement since it will go to YouTube. Otherwise I could have said yes, it will occur. Theoretically though it will occur, obviously.
theoretically, yeah, okay, fine, but
If it is damaging or anything, I am not sure with that.
It's separating. That's what we want. We want
The whole thing is electron should come out. electron should come out. That is the main thing. If you give enough, it's basically conservation of energy. You give energy, it will come out. Khatam. That is basically that.
Turn off the video.
Oh, why?
Because you told
Question karo.
I thought it not explained.
No. अच्छा ठीक है. You can turn it off.